A dot plot is another way to organize your data and create a visual display of your data set. The first example gives the fuel economy in miles per gallon of a sample of cars. So we can see the scale down here goes up by 2, so 16, 18, 20, and so on. So the data set, the range from 16 to 24, the range would be 24, because 40 minus 16. So that's why they use a scale of 2 here. If your data set was even further apart, then you could use a smaller scale. Obviously, if it was closer together, you could use a smaller scale. What the dots are, each individual dot represents an individual car. So the miles per gallon of an individual car. So there's one car that got 40 miles per gallon. One car on the other end got 16 miles per gallon. You can see the most dots occur at 31. So halfway between 30 and 32 is 31. And there were 1, 2, 3, 4, 5, 6 cars that got 31 miles per gallon. So with this dot plot, we can get an idea of how the data is spread out. Now, one thing we might look at in a set of data is, are there any unusual data values, or are there any outliers? Now, it might appear that 16 is an outlier, 40 is an outlier. Okay, it may look like that, because those look like data values that are far away from what we would expect to find a typical data value. Well, if we look at actually entering these data values into a calculator, I already did this. If you want to, you can, or you can just go along with what I show you here. Trying to get it where it doesn't. Okay. Okay, so if I put the values into list 1, so I just put each individual data value in 16, 23, 24, and so on, and 31 occurred 6 times, so I put that in 6 times. So that's the way that I enter the data in. Okay, if I calculate the 1-var stats, so stat calculate 1-var stats on list 1, okay, it gives me a mean of 29.3. So 29.3 on our graph, try to get it so we can see the whole thing. 29.3 will be right around here, which kind of makes sense because even though the bulk of the data lies between 30 and 32, the fact that we have a handful of, well, 3 values here that are a bit off to the left and only 1 value that's a bit off to the right, that's going to bring the mean down from this chunk right here. Okay, so it just brings it down to 29.3. Okay, if I scroll down on my calculator for the median, it gives me a median of 31. So the middle number is the same as the mode, which is at 31. Okay, so this is a case where when you graph these, the median didn't really shift any from where you would have expected it. Okay, right here, the same as the mode. Now, what I am interested in terms of outliers, Q1 and Q3. Remember, to find an outlier, you have to find the IQR, which is Q3 minus Q1. So if I do Q3 minus Q1, the IQR is 3. Okay, so that's just Q3 minus Q1. And then if I multiply that by 1.5, I get 4.5. Okay, so remember, if you go 4.5 above Q3, well, Q3 is at 31, add 4.5, you get 35.5. So anything above 35.5 will be an outlier. So 40, it looks like, is an outlier. On the other end, if I go 4.5 below Q1, so 28 minus 4.5 is 23.5. So right here, Anything to the left of that would be an outlier. So 16 and 23 are both outliers. Okay, so the left end has one more outlier than the right end does. Okay, so that's one way looking at a dot plot can help you get an idea of what your data set is doing. Okay, another example of a dot plot is just an age of people at when they died. Now, whether this represents a town or a small city, whatever, we're not concerned with getting into too much depth. But just what I want to bring up here is that you notice the scale on this one, 24, 36, 48, and so on, that's going up by 12. So it's harder to tell exactly how much or where a dot is. So for example, looking between 48 and 60, it's hard to tell what these two dots would be. Now you might guess like 49 or 50 and then maybe 50, 52, somewhere in there. Okay, but if we go to where there's more data, then it looks like we have these dots that are not skipping any spaces. Okay, so right here between 60 and 72, you can see how there's a space skip between these two. Well, as you go into the bulk of the data, it doesn't look like any spaces are skipped. So it looks like if I look between 84 and 96, there's 84. Now, if I think it's going up by ones, that'd be 85, 86, 87, 88, 89. Well, we have to go 7 more to get to 96. So is it going up by twos? Well, there's 84, 86, 88, 90, 92, 94, 96. So it looks like the scale, well, I should say where they're putting each dot, represents a distance of 2 years. Okay, and you could do the same thing to estimate the mean, median, mode in this. The mode, the one that occurs most often, it looks like is about 92 right here, because that's the highest one. If you're trying to estimate the mean and the median, well, it looks like this one's a little bit skewed to the left because this handful of data values out here, if you covered those up, then this right here would look fairly symmetric. Well, these few data values on the left is going to pull the mean down. So you might guess that the mean, instead of being right at maybe 80, 88 or 90, you might guess is closer to maybe 82 or maybe 80. So somewhere's down in here. And the median you would guess is around 84 or 86, somewhere's in there. Okay, and then the last example is just to show you that a dot plot does not have to be numerical data. It could also be qualitative. And that's something you should always pay attention to when you look at making a graph. The kind of graph that you make depends on what kind of data you have. Okay, there are some graphs you cannot make with different kinds of data. So you have to pay attention to that as you go through these videos. Okay, so they just give you an example of a class's favorite snack. Okay, and what you can do with qualitative data is you can find percentages. So you could ask what percentage said popcorn was their favorite. So you would take the number of popcorn divided by the total number of choices, or of dots. I don't have them all added up, but you get the idea. Okay, mode, so popcorn occurs most often. Now talking about a mean or a median would make no sense here because these are just categories. You can't find an average of a type of candy.